On a continuous foaming line, uneven cell size, unstable cross-directional distribution, and fluctuating creaming often trace back to the mixing stage. This stage is very short, but it directly affects the condition in which the liquid enters the later foaming and forming process. Once the raw materials enter the mixing head, the components need to be mixed uniformly in a very short time and then poured continuously onto the conveyor. What is decided here is the initial condition in which the liquid enters the later creaming and forming process. If the condition is not right here, the downstream section no longer receives a stable starting point, and the burden on the forming stage increases immediately. A mixing head usually includes the drive section, the material distribution section, the mixing chamber, and the nozzle. The drive section provides the mixing power. The material distribution section feeds each component into the mixing zone. The mixing chamber affects how the liquid is mixed inside, and the nozzle influences the final flow condition leaving the head. How well these parts work together directly affects whether the mixing result stays stable. The mixing chamber is especially important in this stage. Its size and internal structure affect both the mixing process inside the head and the shear condition applied to the liquid. If the residence time or mixing condition is not suitable, the materials may not be fully mixed, and the condition can become more unstable. So the mixing chamber is not just a simple passage, it directly affects the state of the liquid when it leaves the mixing head. Mixing speed also has to be judged together with actual site conditions. If the flow rate changes, the suitable mixing condition will also change. If the formulation changes, the requirement for mixing energy will change as well. So in practice, the more useful way to judge this is not to focus on one speed value alone, but to see whether the mixing condition can stay stable under the current set of operating conditions. The dispersion state of the liquid before it enters the downstream section will affect the later cell structure. If the mixing condition is unstable, or if gas dispersion in the liquid is poor, the cell structure becomes more likely to fluctuate. This also has to be judged together with the formulation, because the same visible condition can still produce different results when the chemical system changes. The nozzle also affects the pouring result. It influences flow speed, distribution condition, and splashing behavior. If the nozzle is not properly selected, then even when the upstream mixing condition is basically normal, the flow can still start to become uneven during pouring, and the later cross-directional distribution can be affected very quickly. So what matters most in this stage is whether the liquid leaving the mixing head is stable, whether the pouring stays continuous, and whether the downstream section receives a stable starting point. Once this part is well controlled, the later creaming and forming stages have much better conditions for staying stable. In the next episode, we will continue downstream and look at how the foam block gradually takes shape during continuous conveying. If you want to understand the 7 key factors that affect the long-term stable operation of a continuous foaming line, please leave your email in the comments, and we'll send you the document later.